Good day and welcome back. So it turns out my curiosity got the better of me again. I was looking at the charge graphs for these two old AGM batteries I have been testing, and I noticed something weird. Well, weird enough that it was worth making a video about. So if battery quirks and questionable hardware behavior and accidental success stories are your thing, buckle up. For anyone not following the saga, long story short, I've been trying to revive a pair of 18 amp hour AGM batteries that were basically 1 foot in the grave. The very first time I ever tested these batteries, they were measuring around about 900, 800 milliamp hour each. So I decided to just chuck these two batteries onto the cottage emergency lights because the NeoPixels don't draw more than 400 milliamp when both of them are on. So this seemed ideal just as an emergency light setup because that would last at least two to 4 hours. I've left them on the Pico charge controller and 20-watt solar panel that's connected to the cottage batteries for a month and a half. And the one evening I was messing around with the NeoPixels and I noticed these two batteries are really holding up quite well when the NeoPixels were on. So I decided to start running tests on these two batteries. The first test that I ran them in parallel, and I only used the 3 nodes that I had connected to the two physical batteries as a load. Those 3 nodes draw came to, I think it was 124 milliamp. So it took 6 or 7 days for these batteries to drain down to 12 volt, which is where I consider my personal cutoff for any lead acid battery or any battery for that matter. So needless to say, after noticing this, I decided, well, I think I'm going to charge them up and then retest them individually. Now the second test that I ran on them individually, the one battery I managed to squeeze out 11 amp hour on I think it was a 1 amp set of globes as a load. The second battery I managed to squeeze out 8.7 amp hour, but now I do have to mention these load tests were done all the way down to 11.4 volt, which I do not like doing at all. So I reran the tests again after these batteries were charged up, and if memory serves, let's go here, I managed to get 11.5 and 8.75 on the first run. Then I redid the tests again and I managed to get about 12.5 out of both of them, but this was only down to 12 volt. Not liking to go down below that. That's my load test cutoff voltage. So when I started recharging these batteries, I noticed the Pico solar charge controller was giving off this very odd, as you can see here, these dips happen every 18 minutes and 45 seconds. Now I'm assuming whoever manufactured this charge controller did this so that the charge controller can ascertain what charge state it's in, whether it's in float, absorption, bulk, whatever. So this charge controller basically cuts off every 18 minutes and 45 seconds, checks what voltage, current, whatever, and then continues doing whatever it needs to be doing. I have a very funny idea. These dips are what caused the recovery of these two AGM batteries. So what I have done is I basically reran this similar test on a different battery and tried charging it up in a similar fashion, but I'll get back to that a bit later on. Okay, so anyway, I just initially I thought this was like a glitch, but like I say, the more I looked at it, the more it felt intentional, almost like the charge controller was stopping momentarily just to check the battery's resting voltage, state of charge, whatever the case might be. So I basically did this on a different battery. Now I realized this voltage is way below what a battery should ever go down to, but this battery wasn't delivering the capacity that it should have to start off with. It would start the load test at 12.4, so in other words, charge it up, rest it, put the load on it the next day, and it would start out at 12.4 and then gradually decline all the way down to 12.33, and then it would just drop off all the way down to 10.364. So what I did was on my capacity tester that I built up, I have now gone and added a relay and OLED screen and all kinds of other nonsense to it. And I took this specific battery and started pulsing the lower end. As you can see here, it is physically bottoming out. It doesn't go lower than 10.364 at all, ever. It just gets down to 10.364 and it sits there for the balance of the time that this load is physically on the battery. So, as I say, I then came up with an automation that pulses this on until it gets to 13.6 volt, and then it switches off with a very light load still connected to it. So in other words, it's not going to take any physical charge, it's just going to try and recondition the bottom end. And as you can see here, these steps get flatter and flatter and flatter throughout the entire time. This was after, I can't remember, probably 6 hours of doing this. You can see the voltage is actually now bottoming out at 10.48, not at 10.364 like it initially was. So I thought, well, this does seem to be doing something, so I carried on doing that for a bit longer, and lo and behold, it landed up lifting the floor cutoff of this battery to 10.6 volt. So this is a really good sign that, I mean, that you can physically raise the bottom end where this battery is now cutting off to, and get it to stay steady at that voltage. It never dropped back down to 10.364 ever after that. No matter how much I kept the load on it, it just never went below 10.594 for some odd reason. So I decided, well, prematurely, I decided to charge the battery up to full, and it is currently on a load test. Now, I can guarantee you now there's still a cliff. This battery is probably going to get to about, at a guess, I would say 12.25, 12.25 volt, and then it's going to drop off again, but it's going to drop off now to the new 10.594 voltage. If it does that, what I'm going to then do is carry on with this pulse cycling at the bottom end of the battery just to see if I can recover this bottom end to start holding a charge at all the way up to 12 volt. I'm hoping. I'm not sure if it's going to work, but from the 8 hours, 9 hours that I had this just pulsing the bottom end, it managed to lift this bottom floor from 10364 to 10594. So that in itself, 200 millivolt, is not peanuts. So I'm kind of hoping the battery levels out at 12 volt. If it does level out at 12 volt, I'm not going to be redoing this bottom end. Then I know I can take one of the 2 dud batteries that I got, that I only got about 2 or 3 amp hour out of, and I'm going to try and do the same thing and see if I can maybe get some more capacity out of that. But if it falls off a cliff and goes back down to 10.594, then I'm going to do another bottom end cycle. If it doesn't, I'm going to stop the load test at 12 volt and see what the new capacity is of this battery. So currently I had it on since 11:15 this morning. Let's just get rid of that one. This is basically just the 2 dud batteries that I put onto my Home Assistant just to see if I could keep Home Assistant alive a little bit longer. There's the 2 dud batteries, and then it just cliffs off to where the existing AGMs are, but it's definitely not making the prerequisite 18 hours of load. But anyway, okay, so like I say, started the discharge on this battery at 11:15, and it dropped down to 12,633, which is unusual for this battery. It always dropped down to 12.44. So it does look like the upper ceiling, where its resting voltage with the load on it, has actually increased slightly. And it does physically look like it's plateaued very nicely. So I'm going to give this battery one more load test to see where it cliffs off, and I will then take it from there, and hopefully, very hopefully, it doesn't cliff off and it just carries on draining all the way down to 12 volt, because then this battery is definitely going into service for the Home Assistant. But this weird dip every 18 minutes and 45 seconds is what I have basically tried to replicate on this battery when I recharged it. It didn't seem to get much more capacity out of it. It seemed to be right on what it used to be. I mean, 50 milliamp hours not going to break anybody's bank. So on recharging it, it didn't seem to have that much of a difference. But on the drain, on the load test now, I suppose we'll get to figure out if it's improved whatsoever. You can actually see here where the automation that I've programmed into the node is now physically charging it up, waiting for it to reach an additional 1% state of charge, and it cuts off, gives it a rest, goes back up, gets the additional 1% state of charge, cuts off. So it's been doing that all the way to full. So I'm kind of hoping that this battery will now recover. But anyway, we will see. I just thought I'd share this weirdness. Maybe it helps someone else, maybe it just satisfies you in a nerd for the day. Either way, I'll probably rerun the test again once it's fully drained. depending on obviously if there's this drop off at 12.22, then I'm definitely going to be cycling it. But anyway, if you feel like following this chaos, feel free to hang around. If not, well, at least you know what accidental battery therapy looks like. And I will be catching you on the next one. Thanks for watching. Bye.